Okay, so last couple sections we're going to look at are in Chapter 7. We'll look at 7.2, 7.3, and 7.4. If we had an extra day, Section 7.5 it's kind of an interesting one because it gets into like mortgages and calculating like interest rates and kind of some practical stuff if you're interested in all with banking and how that kind of stuff works. So we could figure out problems like, let's say, you put in $1,000 in a savings account and you don't touch it for a year and it makes 2% interest. How much money would you have after the end of the year? Okay, so we could figure out how much money you would make. We could also figure out things with like a loan, how much money you would end up paying. So if you borrow $150,000 to buy a house and you didn't make any extra payments on the principal for 30 years, you'd end up paying back a lot more money because of the interest. We could figure out how much money you'd pay the bank back on top of what you borrowed. But I don't think this week we're going to quite get to that. All right, so basically logarithmic functions are the opposite of exponential functions. Let me just show you a quick picture of an exponential function. An exponential function is a function that starts out very flat, and then all of a sudden it curves up extremely fast. Okay, so exponential functions go up very, very fast. Log functions are kind of the opposite. Okay? They go up very, very, very slowly. Okay? In fact, even if I zoom like way over to the right, if I let x be 100, on the exponential function, it's huge. It's 1.3 times 10 to the 30th power. Very, very high. But on the log function, when x is 100, y is only at 2. If I let x go to 5,000, now the exponential function is so big it's can't even calculate it, but the log function is only at 3.7. Okay, so when x is 5,000, y is 3.7. So logarithmic functions go up very, very slowly. And the idea is if you take a logarithmic expression, like the one I graphed, 2 to the x, set it equal to a number, we want to solve it for x. What makes that a little harder to solve is that the x is an exponent. It's up in the variable. If you had something like this, that's a lot easier. All you'd have to do is divide by 2. But when the x is a variable, you can't use division or multiplication to solve it. Okay? So the only way to solve something like that is with a log. Okay? Unless it happened to be one that was simple enough you could do in your head, because 8 is a power of 2. 2 to what power would give me 8? 3. Okay, so that one's easy to solve. But if I change that number to a 10, well, it's not 2 to the 3rd, because that's too small. 2 to the 4th, that's too big. So what is the exact answer? We could figure it out with a log. Okay? So eventually, that's the goal, to figure out stuff like that. Okay, so what I wrote on the other page, that was an exponential equation, because it had an equal sign in it. This is even simpler. This is just an exponential expression. It's not even equal to anything. It's just a number raised to a variable. Once you take something like that and then set it equal to something, then you've turned it into an equation we can solve. Okay, but we're not going to do that yet. So during the week, we're going to talk about 2 different ways we can write things. Okay, one way is going to be with exponents. Okay, we're going to call that exponential form. And the other way we're going to write something is with a log. We're going to call that logarithmic form. Okay, and what I'm going to show you right now is the formula to convert between the two. And this formula is going to work both ways. You can change exponents to logs and logs to exponents. And really, the way the formula works, it's more of something you just need to memorize. It's kind of what's going to end up moving where. There's no real calculation or any arithmetic or anything like that. You just have to learn what moves to what spot. Okay, so here's the formula. Okay, what I've done in the formula I'm going to give you, I've highlighted different things in color, so you can kind of see what moves where. So that is going to end up moving there. Exponent ends up right there. And then the only thing we haven't used is the x. And that's going to go right there. Okay, so let's kind of look at what happened, because it's not random. There's kind of some reason why it got rearranged that way. So what's on the left is exponential form. Okay, how do you know that? Well, there's an a with an exponent of y, so it makes it exponential. On the right, that's log form, because it has the word log. Okay, when you write something like that, okay, we know the 6 is the exponent. Anybody remember what the 3 is called? The number that's lower than the exponent? Oh, Connor? Remember what that's called? The thing that, this right here? Not sure? About Peter?
Base.
The base, right, it's the base. So the number that's lower than the exponent, that's called the base. Well, when you rewrite it, okay, a was the base on the left. This a is a little bit lower than the word log. That's called the base of the log. So the base on the left becomes the base on the log. Okay? It's written a little bit lower than the word log. The next thing is the exponent. I told you that anytime you want to solve an equation that has an exponent with a variable, you have to use a log. So if you can remember the idea that a logarithm always equals the exponent. So logarithm always equals the exponent. Y was the exponent, and the logarithm equals the exponent. Y. Log always equals the exponent. Okay, and then if you can remember where 2 out of 3 of the things go, then the third thing is the x, and there's only one spot left for it. Now, on the right-hand side, just to make it clear how that's, like if you were on lined paper, how that would look. This is the word log. Okay, the word log is right on the line. The base of the log, which is normally a number, would be written a little bit lower. And I'm just picking another number. 3 would be written right on the line. The 3 is not an exponent. The 5 is an exponent. Okay, that's log base 2 of 3 to the 5th. But if I just have this, there's no exponents in that at all. The 2 is lower than the word log, and the 3 is right on the line with everything else. The way you pronounce that is the way I just pronounced the one on the other page. Y equals, we should read it left to right, log base A of x. Okay, so the answer that you get when you take a log depends on 2 things. It depends what is the base, and it depends what's the thing you're taking the log of. It's kind of like if I said to you, let's take a root of a number. Well, the answer that you get depends on 2 things. What kind of root are you taking? Are you doing square root, cube root, what kind of root? And what are you taking the root of? 6, 7, it depends. So In that case, I'm taking a square root, and the thing I'm taking the root of is 5. In that case, I'm taking a cube root, and the thing I'm taking the root of is 12. Okay, with logs, in this case, I'm doing a base 2 log, and what am I taking the log of? 3. If I did something like this, now I'm taking a base 6 log, and what number am I going to use to do it? I'm taking it of the number 12. All right, so for now, we're going to stick with 2 bases that the calculator can do. The calculator can't do those 2, at least not by pressing a single button. But I'll show you the 2 that the calculator has buttons for in a little bit. All right, so let's practice changing something that's in log form to something that's not log form. Now, there's nothing you're going to be able to solve here because we don't have enough numbers in the problem. All we're going to be able to do is rearrange it. Okay, but you're not going to get a numerical answer. Okay, so let's start with the base. Haley, what's my base here? Well, log is that's the function. It's like, are we doing the sine of x? Are we doing the square root of x? Are we doing the log of x? In this case, we're taking the log of x. So that's the function name. 3, yep. So we're doing a log. That's the type of thing we're doing. Specifically, we're doing a base 3 log. So the base is 3. Okay. So when I rewrite this, my base is going to be 3. All right, so next thing we have to figure out is the exponent. So Paige, I said earlier that the logarithm always equals the exponent. So what is the logarithm equal to here? And what is that equal? So in this case, everything on the right-hand side, that whole log is equal to... Oh, yeah. No, the x is on the right-hand side with the log. But what's all that equal to? So this is all equal to something. No, y. That whole, did you say y? Yeah. Oh, I didn't hear you, I'm sorry. That whole log is equal to y. Yep, the whole thing. So whatever the logarithm equals, that becomes the exponent. Sorry about that. All right, so 3 to the y equals, and now there's only one thing I haven't used, and there's only one spot left to put it. So Molly, what's the only thing I haven't used? X, and that's going to go by itself. So rewriting that in log form, it says x equals 3 to the y. Now if we knew y, like let's say y was 2, then we could fill it in and say, oh, x is 3 to the second power, and we could get an answer. But in this case, we don't know that. Okay, let's try this one. So it says y equals log base 5 of x. Okay, Ashlyn, what's my base here?
The base is 5.
Yeah, so the base, it's always the number that's lower than everything else. We're going to plug that in as our base. Next thing I'm going to figure out is my exponent. Irene, what's my exponent here?
1.
Yeah, the logarithm always equals the exponent. So whatever that's equal to, that's always the exponent. And then if we know those 2 things, there's only one thing left. So Connor, what's the last thing I haven't used yet? The x, and where does it have to go?
On the left side of the equal side.
Yeah, you don't have anything on the other side. You gotta have something there. And that's the only thing we have left to use. Again, same idea as example A. If we knew y, we could plug it in and do 5 to whatever power and get an answer. Okay. Any question on that? Now, in other classes, some people said they've studied logs before. If you write that, that's the same thing. No difference. Okay, so now let's try it. Let's try the other way. We're going to take something that is in exponential form, and now we'll change it to a log. Okay, if I'm going to change this to log, what do you think the very first thing I should write down is? That makes it very obvious it's a log. Yeah?
Log.
Log. Yeah, put the word log. And now we'll fill in everything around it. Now, what's my base on example 2a? 1.2. So whatever the base was originally, that's going to be the base on the log. So what that means is if you were typing this in, you're using the log function on your calculator, but more specifically, you're doing the log function with a base of 1.2. Eventually, we have to learn how to type that in. Well, Katie, I said that the log function always equals what kind of number? Yeah, it always equals the exponent. So logs always equal the exponent. Okay, and Mason, what's the only thing I haven't used? The m, and that has to go into the log function. What I have written right now is kind of like this. I have a function, but I don't have any number to plug into it. I'm telling you to take a cube root of what? Put something in there. Same thing here. I'm telling you to take a log base 1.2 of, put something in there, of m. Okay. Any questions on that? All right, let's try this one. E to the b equals 9. Okay. Anyone think they could tell me what it would be when you change that to log form? Yeah?
Or is it the entire thing?
Yeah, sure. Go do the whole thing.
I'm pretty sure it's b equals 1 with the base of e, and that last one is 9.
Yep. So b equals log base e. That's the type of log you're doing. And then tell the person what you're taking the log of 9. Log base e of 9. Now I'm going to come back to that one because you would never see something written like that. Okay? It's perfectly fine the way we did it, but there's one more thing you would normally have to do. Okay? So, and I'll mention that when I talk more about that base. Okay, that e is something special. But for now, we'll just leave it like that. Okay, let's try one more. So this one says a to the 4th equals 24. Alex, can you tell me how to rewrite that in log form?
That would be 4 equals log with a base of a and 24.
Yep. So he told me 4 equals, we're taking the log with the base of a. That's the type of log we're taking. And then what number are we going to use to do that? We're going to use the number 24. Okay, any questions on that one? Okay, so when we start to solve equations, that's generally one of the most important things we can do. Either change it from log form to exponential or the other way around. Okay, here's another one that's just going back the other way, but I'm going to mention something about e in this problem. Alex, what's my base here?
Is e.
E. That's the type of log I'm doing. Log base e. So e is my base. What would be my exponent here?
-3.
Yep, logarithms always equal the exponent. Now, if you look at that, you might be like, well, there's 2 letters there, but not really. E stands for something. If you call E a letter, well, then in math, that's like saying, well, that's just a letter. Well, it's a letter, but it stands for something. There's a number behind it. So like pi, we get 3.14. Does anybody know what E is? Anybody used E before? Yeah? Just switch to 2 points. You said 2.17, 2.71. Yep. And on most scientific calculators, there's a button for it. It's like pi. Okay, it never ends. It looks like there's a pattern that repeats. 1828, 1828, but it doesn't keep repeating that way. I don't remember the next digit, but it's not 1828 again. Yeah.
There's like a 90% chance I'm going to pass out right now.
Okay.
So if I pass out, just should be all set.
Yeah, you want to go down and... All right, so E is the number 2.718. So it's just a special number in math. It's not used as much as pi. Most people aren't quite as familiar with it. But the reason I'm showing you that is because you could actually type that in on this calculator. You could type E to the -3rd, and you could actually get the answer. Okay, in this case, I'm not interested in 0.049787. Okay, all I wanted you to do was write that. Okay, so any questions on that one? Okay, and I'm going to talk more about that in a second. And we saw that come up somewhere else, right here. This log base E. That has a special name. All right, so now we're looking at one that actually says to solve. Since I haven't shown you how to type anything in on the calculator yet, this has to come out to a nice answer. It's going to be nice. So, anyone have a suggestion on what I could do here? It's the only thing we know how to do up to this point with logs. Yeah?
You can change it.
Yeah, let's change it to the other form. If changing it to the other form doesn't work, then we're going to be stuck. Could you change it for me, Ashley, and tell me what it would look like?
Yeah, give me 1 second to do it on my hand. Okay.
Yeah.
Equals.
Well, 2 is going to be my base, right? So 2 is my base. What about my exponent?
But you guys,
Where do we look for the exponent?
It's x.
X. So we look for the exponent by, we look at the log equation, whatever's by itself on the other side, whatever it's equal to, that's your exponent. And what's the only thing I haven't used? 16. So now, like I said, since I haven't shown you how to type it in, that answer has to come out nice. So 2 to what power would give me 16? Yeah, exactly. All right, so 2 to the 4th power, that gives me 16. Any questions on? Now, if you're wondering, well, what if it was 2 to the x equals 17? Now it doesn't come out nice. Then we could type it in on the calculator, and I'll show you how to do that probably tomorrow. All right, let's try this one. It says log base 5 of 23. 25 equals x. Right, so Faith, what's my base here?
5.
Yep, so 5 is my base. Emily, how about my exponent?
X.
Yeah, whatever the logarithm equals, that's your exponent. And the only thing I haven't used yet is the 25. Okay, so now at this point we just have to be able to look at that and figure out what x is. 5 to what power gives me 25? 5 to the what? Yeah, second power. Okay, sometimes people look at it quickly and they say, oh, 5. Remember, we're not thinking 5 times 5. That's 25, but this problem is 5 to what power? 5 to the second. Okay. Any questions on that one? All right. So this one's a little different, okay, because it has a fraction. But if you look at 27, you look at 3, 27 is a power of 3. Right, so if we start to rewrite it, that's my base, that's my exponent, that's what goes on the other side. Now, if you get stuck looking at that and you're like, well, 3 to what power would give me the fraction 1 over 27? First, look at this one. See if you could figure out 3 to what power would give you 27. And then if you figure that out, exponents that are certain kinds of numbers cause it to flip. So, Peter?
-3.
Would be -3. Yep. So whenever you raise a number to a negative power, that's when you get a fraction. And the nice thing about that, you can easily check it. Let's try 3 to the -3 and see what we get. So 3 to the -3 gives me 0.037 repeating. Well, let's just change it to a fraction, or change fraction to a decimal. Yep, that's 1 over 27. So it works. So keep that in mind. If you need a fraction, solve the problem like it's not a fraction, and then make the answer negative. Okay, so the letter E. Okay, so E is it's an English letter, but in the context of logarithms, E stands for the number 2.718. Okay, just like I said earlier, pi. Pi is a Greek letter, but in the context of geometry or anything with circles and spheres, it stands for the number 3.14. Okay, and there's a lot behind that number, like why is it 2.718? Like where does that come from? It does come from somewhere. That's not really something we get into. So there's 2 logarithms that we study that have special names. And what I mean by a special name is if the base is an E, it gets a special name. Or if the base is a 10, it gets a special name. Well, if the base is an E, okay, if you have something like that written, what I just put a box around, we can shorten that to that. It's lowercase l, lowercase n. So it doesn't shorten it much, but instead of writing 4 letters, you can shorten it to just writing 2 letters. So log base E means exactly the same thing as lowercase l, lowercase n. So it's just an abbreviation, that's all. There's a shorter way of writing it. And the lowercase l, lowercase n, that's actually the name of how you pronounce it. That's called a natural log. So you might be like, well, why isn't it NL? Natural log. Yeah. That's just the way they write it. So anytime you're doing a logarithm and the base is an e, you're doing what's called a natural logarithm. And there's a button for that on the calculator. Bring it up. Notice there's no button on here that says log base e, but there is an ln button. Lowercase l, lowercase n. And now I could type in something like that. Tell me the ln of 8. That natural log of 8. Okay, so that's the first log that has a special name. Okay, base e, we abbreviate it lowercase l, lowercase n. It's called natural log. Okay. Now that we know that, let's change this to an exponential expression. Okay, what you have to be careful about if you use that abbreviation, it hides the base. You have to remember what it is, though. Okay, you have to remember that the base is e in order to do something like this. Okay. So let's start with our base. Okay. Orion, what's my base here? Remember, it's hidden.
Yeah, so would it just be n or would it be l?
That's the function name. That's the operation we're doing, like square root, whatever. We're doing a natural logarithm, but the base is hidden inside that abbreviation.
So it would be
E, yes. So if you want to rewrite it as an exponential, we got to remember what that base is. So E, what would be my exponent? Yep.
X. Oh no, 8.
8, right? Logarithm always equals the exponent. So my log, I'm taking the logarithm of, natural logarithm of x, and that equals 8. So now, I've got my base. My log was equal to 8, that's my exponent. And that's it. So e to the 8 equals x. And now that's something I could type in on the calculator and get the answer if I wanted it. But the question didn't say to do that. Hey, any questions on that? If they want you to do it out, like how you're saying, well, how would I know if they want me to do it out? It'll say in the directions, change to an exponential, round your answer to 2 decimal places. Any questions on how you would type that in? Yeah?
Yeah.
So it's different on every calculator. On mine, I press second E, and then I hit the exponent button, and I type in E. If you have a calculator that's a graphic one, you can do it exactly the same way. If you have a scientific one, I might have to take a look at it and help you out. What you could always do is, if you know what E stands for, 2.71828, you could always just type it in by hand. As long as you type in that many decimals, it'll be accurate enough. And then raise it to the 8th power. That would be close enough. Generally though, if the answer starts to get really big, they're not going to have you do it out. Okay, that's a little bit big, but if the exponent was, say, like e to the 20th, that's going to be huge. Okay, you're not going to have to do out something like that. But a small one, that's how you type it in. Okay, if you can't find e on your calculator, just let me know after, and I'll come take a look. That's the same thing. All right, let's look at this. Okay, so I told you there were 2 logs that had special names. This is the other one. Okay, common log. If you're doing a log and the base is 10, that's called a common log. So if it's a base 10, it's a common log. If it's a base e, it's a natural log. If it's anything else, there's no other special name. You just say it's a log base 7 or log base 8, whatever it is. So that's an example of a common log. Log base 10 of 5. That's also an example of a common log. Log 40. What's different besides the actual numbers? What's different between the two examples I just wrote? There's no base on the second one. Well, if you're doing a common log, you don't have to put the base. Okay, if the base isn't written, we assume you want common log. We assume the base is 10. It's kind of like in algebra, if you write an x, we assume you mean 1x. There's a 1 in front, but you don't have to write it. Same thing here. If the base is not written, you assume the common log. And that's how the calculator does logs as well. If I press the log button on the calculator and I type in 40, it's not going to put base 10 on it. It's going to assume that that's what I want. So if I want the log of 40, I just press log 40. And the calculator automatically just gives me the log of 40 using base 10. But what if I didn't want base 10 or base e? Well, there's going to be a way to do that, and there is. And I'll show you tomorrow. You can do any base you want in the calculator, but those are the only two you can do by pressing a single button. Base 10, base e. Also, I might not have mentioned it, but the base has to be a positive number. You can't do negative bases. That doesn't work. All right, so here's our first real kind of somewhat substantial log equation. Okay, if you didn't know anything about logs, you'd be stuck. You wouldn't know how to solve that. But there's one thing we know how to do with logs so far. It's the only thing I've taught you. What can we do with an equation that's in log form? Tell me what the one thing we can do is. Yeah?
Exponential expression.
Yeah, we can change it to exponential. Okay. So that's what we're going to do. We're going to change that to an exponential expression. And I guarantee once you rewrite that as an exponential expression, all you're going to need to solve it is algebra 1. Okay, so let's start with our base. Okay. Emily, what's my base?
Is it 3 or is it 2?
3. Yeah. So the base is whatever. If you had a line in there, it's whatever would be below that line. So my base is 3. Okay. How about Connor? What's my exponent?
2.
Yeah. Remember logarithms. That's the logarithm. Logarithm always equals the exponent. So I've used the 3, I've used the 2. Cameron, what's the only thing I haven't used?
4x minus 7.
Yeah, I haven't used the thing that's right next to the log, 4x minus 7. And now we solve that for x. So Peter, what would be my first step to solve for x there?
I would figure out what 3 squared is first.
Yep. And what would that be?
Equals 4x minus 7. You add 7 to both sides.
Yep.
And you get 16 equals 4x. And divide both sides by 4.
And divide by 4. So we get x equals 4. And that's the answer. So once you change it from log form to exponential form, then from there it's just algebra 1. Just get x by itself. Sometimes the equation is a little bit more complicated than that. That was really a two-step equation where you had to add to both sides and then divide by 4. 3 squared, probably could have done that step in your head. So that was really, I would say, 2 steps. Okay. Sometimes it's a quadratic equation. So if it's a quadratic, then factoring can come up or quadratic formula. Don't think any of these are going to have quadratic formula today. But probably tomorrow or Thursday. Okay, so that was one where the variable was in the log. This part of the log, I don't think I told you this. What's in the parentheses there, that's called the argument. For x minus 7 is the thing you're taking the log of. And we've seen arguments all year. Sine of 45 degrees. That's the argument. It's the number that's, something's happening to it. In this case, the sine is happening to it. In that case, the log is happening to it. Okay, so the argument is just the thing that you're using in your function. Let's look at this one. Haley, what's the argument in that one?
That equals 2.
Well, it equals 2, but what's the argument? Not sure. Anyone help her out? What's the argument there? Yeah.
64.
64. It's the thing that you're taking the log of. Okay? In this case, you're taking the log of 64. Specifically, you're using a base of x. Okay, we don't know what the base is. But that's the difference. This time, the base is a variable. Last time, the argument had the variable. Okay, so I've moved the variable to a different spot. But we're still going to do the same approach. We're going to change it to exponential form. Okay, anyone think they can change that to exponential form for? Yep, Rudy.
Base is x.
Base is x, yep.
The exponent's 2
Perfect.
equals 64.
There you go. So it's x squared equals 64. Now this time we can't add, subtract, multiply, divide to get x by itself. What do I have to do to both sides here? Yep.
Square root.
Take the square root. Square root. Square root. Now I told you earlier that the base always has to be what kind of number? Well, it's a number, yeah. Well, what kind of number?
Positive.
It's got to be positive. So technically when you take the square root of 64, there's 2 answers. 8 times 8 is 64. So is negative 8 times negative 8. But because we're dealing with a base, we don't write the negative answer. Just x equals 8. Any questions on that one? Okay, so we looked at one where the variable was in the argument. We just did one where the variable was in the base. And now let's look at one that we have a variable up in the exponent. First, I just want to look at that. What kind of equation is that? Is that a log equation or exponential equation? Anything, Ashley? That's exponential. Well, when it was a log equation, we changed it to exponential. When it was a log equation, we changed it to exponential. This is already exponential. So what do you think I'm going to do with this? We're going to change it to log. If that doesn't work, then we're stuck. That's the only thing we can do. So we'll change it to log. And Alex, what will my base be on the log?
E.
Yes. So that's a log base e. We're going to come back to that. We talked about that earlier. So log base e. And the logarithm always equals the exponent. So Connor, what's my exponent here?
2x.
Yep, 2x. And then the last thing I haven't used yet is the 5. And does anybody remember what is the number called that you put right next to the log function? It's the, yep,
Argument.
it's the argument. The argument is 5. Okay, let's start with the right-hand side. What can I shorten up on the right-hand side? I can write something there a little shorter. Oh, Matt?
Log e cube e ln.
Exactly. It's not necessary, but it looks a little nicer. And now my last step, just get x by itself. How about Paige? How would I get x by itself there? That's it. Just divide both sides by 2. So x equals the natural log of 5 divided by 2. Okay, if you were going to type that in, just to show you something you need to be careful with, you have to type it like that. That's the correct answer. How come I get a different answer when I do it that way? What's the mistake I made? Yeah.
Because it's taking just like
The top one's taking the natural logarithm of 5 and dividing it by 2, and the bottom one is the natural logarithm of 5 divided by 2.
Right. The second, this bottom one, which is the wrong way, is basically doing this. It's taking 5 divided by 2, and then it's taking the natural log of 2.5. But that's not the same as taking the natural log of 5 and then dividing by 2. So just, if you type it in, be careful with parentheses. Okay. Any questions on that? Okay, so that's a good stopping point for 7-2. So the homework tonight, it's all evens on 473. It's 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Okay, you've got just about 20 minutes to get started on that and maybe even finish it. If you want to work with someone, you can. If you finish it, show it to me and I'll check it off. There's some extra books over on the counter as well.
Did you find a book in here last Friday? 'Cause I